But it is understanding a system like this, and the beauty of it, and the strength of it, and feeling it, that is architecture for me. When the concrete is very strong,
when
it is reached, we watch the strength of the concrete because we make cylinders. You know this system? When you place the concrete, you make many cylinders, and you break this in 2 days, you break this in 4 days, you break this in 80 days, you break this in 16 days, you measure how strong.
Yeah.
And when you get the right strength, then you can pull.
Ah, okay.
We call it post-tensioning, right. So this principle, I'll show you now how this develops here. So if we have a principle which is going in both directions, that is, we have a series of beams going in this direction, what more here, 5, and going in this direction, 2, then we will be pulling here and here and here and here and here. We'll be pulling it in all directions. But only after the concrete has reached its strength.
Okay.
I come back to this because I think this is very, very important.
Okay.
Because, say, among other things, I did not have technical people. I had to do it myself.
How?
With placing the concrete first, and here with jacking, with jacks. That is, we pull with jacks, and then we lock it.
Okay.
Lock it. But only after the concrete is very, very strong. And then we pump in here, we pump concrete in under pressure. So it is locked, everything is locked.
Okay.
We push concrete in under pressure. These are the cables and their terminals. And you can see what happens because we have to intersect sometimes, because there's a cable running this way and a cable running that way. One has to go over or under the other. They can't go on the same front.
Yeah.
And so it means the calculation of the condition is different in one direction as against the other direction. And that is the relationship, you know, with the beams, I form them with timber. I make a big box. I'll show you. I make a big box in timber, and this is very, very cheap plywood. So we plaster. This is what I wanted to do here. Just plaster here and leave the concrete. It's on a hillside. So these are the 8 points of support, and they are also, you see here, a bar. That is not a cable, but a bar, which we pull with stress bar. So we stress this bar down to the caissons, which go down below, which we drill into the rock.
Okay.
And then there's a seismic earthquake area, so we have to hold it back. So these are like the rings of a horse coming back into the hill. You see?
Yeah.
Otherwise, all of these heavy lines here are all pre-stressed. These are cables, but these are bars going down to the caissons, down to the caissons. Yeah. And they come to a point which, if I had more money, I could make a proper pivot, we call a pivot, so it can move. It must always move the top freely because of temperature. With the temperature, it moves up and down. Wow. Cheap construction. These are the columns. Start here. You see the bars, bars coming through. There's the tension bars. And which are here again. Ordinary reinforcing steel, but in that is the bar, the heavy bar, which will hold the whole roof down. And there we are when we're just out in the country, when we just got the column first of the 8 columns going up and the pre-stress on the lower level. And then, I think that's me. So we have then the tension bars coming through, waiting. We cut them later on. Okay. But we have to jack them tight and that takes all of the earthquake of the whole roof. The roof is heavy, and so heavy means a force like that. Huh? But that is also, what is so important, is just the element, again what I learned from Miss van der Rohe very much, you know, you just feel the column, the hill, the divisions in the glass, none of us, you know.
Thermical...
Just live with it. First, we're in California.
Bueno, okay.
And it's not we don't have a great range. We have no snow, no extreme heat either. So it's just ordinary glass.
Ordinary.
But in the floor, I put a heating in the floor. But we already have the tendons, we call tendons, are these tension pieces which take the stress inside. 20. Like that, I think we had 20. I mean, something I think I may be wrong. Maybe there were 10. I remember the number, either 10 or 20. But they're in there, just loose inside. When the concrete outside is very hard, huh? And then we have to pull them apart. We have to bring them all apart to a ring. And we thread them then in a ring. I think we had something like this. It's a steel ring with holes in it. And then I think what we did is we had a steel plate outside here and a steel plate outside here, and this plate over it.
Okay.
So each of these pieces came through with the head. And I think we put these heads on. I think we cut them and put these heads on. And then we, in here and in here, we jack it so everything is tight, both ways inside. And we put in here we put a jack, and that means we pull, and then we measure what we're pulling in this direction. We measure it until it moves at the other end.
Yeah.
So we keep on pulling until it moves, and then we stop. And then we read what value we have here. Then we call that friction. There's a friction equals so much. After that, we have a machine in which we could feed concrete into a machine and pump it into the hollow in here. So all of this is then all solid concrete. So it is all bonded. After being stressed, that's why we say pre-stress, then cast.
How long it took to build the...
About a year.
A year?
Yes, about a year.
And how many people were doing all this work?
On this work, most of the time, 3.
3?
My relationship has been very, very strong with all of those 3. Frank Lloyd Wright, Miss van der Rohe, and Le Corbusier. All 3 I knew very, very, very well. And I really worked for these people. And I know, and so they've given me everything I need, you know, really. And so I work from what I've learned. In a building like this, you see all 3 really, it is the discipline of Miss van der Rohe. There's no doubt about it at all, you know. It is the béton blue in the rough concrete, you know. And it is a bit of Frank Lloyd Wright, how it sits in the landscape, you know. But it's not, you don't add one to the other. It's just what one has learnt from really, really great masters. Not a complication of mathematics, I don't mean that. I mean thinking of, you do this first, you know, then you do that, then you measure that, then you must do this. And no one to tell you, you must think it out. And that is So that's my house. That's the basic story.